Hi, and welcome to SketchFormation. In this show, we talk to engineers and developers about how they build and run applications. While they describe the applications, I whiteboard it without them seeing, and then we try to see how much the whiteboard diagram matches up with their reality. In this episode, I talked to Carlos from IBM. He was on a team that ran Cloud Functions, which is based on the open source application called OpenWhisk. This application can take developers' code and run it without provisioning any infrastructure. I was really excited to dive into this with Carlos today and see what it takes to run OpenWhisk at scale. Here's how Carlos describes the app.
I work for IBM, IBM Cloud. I'm an architect, used to be an architect, and for a service in IBM Cloud that is IBM Cloud Functions, and also a contributor for one of the open source project, OpenWhisk. And now I work more with clients dealing with Kubernetes and OpenShift, and also helping them move some of their applications into microservices and serverless, and things like using serverless on Kubernetes, for example, Knative, and doing event-driven applications. So I'm also involved with the Knative project now. But this application today is an implementation of a functions as a service that is based on OpenWhisk, but a lot of the serverless in open source use the same methodology to implement the application. So if you squint, almost all of them look the same.
Thanks, Carlos. Now, at this point, I interviewed him for about an hour and a half, and we focused on 5 questions. The first was, what is Cloud Functions? The second is, why was it built? Third is, from a customer's perspective, how do they interact with the application, and what do they need to do to sign up and use it? The fourth is, what's broken in the past, or what might break in the future? Were there any design decisions that they had to change along the way? And the last question is, how do they roll out upgrades? With a big service and you can't have downtime for customers, what does it take to actually improve the service over time? Carlos did a great job answering those questions. Here's the very end of the interview where I reveal the whiteboard that I was drawing, and I walk him through my understanding of the application and see how close it matches to reality.
Here, this is just where we're starting with, as far as like, this is, IBM Cloud Functions is the basic infrastructure we're describing here, with the URL for it. The kind of why that we were given for, okay, customers wanted to have a no infrastructure sort of execution, just bring your code, run the thing. I thought it was interesting as far as the open source was kind of key for some customers, mainly for that like universal packaging, where it's like, okay, I could run this if I need to exit, IBM Cloud Functions, I could run this on-prem, or even allowing people to say, hey, you have investment in architecture or infrastructure on-prem, go ahead and run this. And when you're ready,
performance, performance, or the data was on-premise,
Right. So yeah, it has that option to switch or possibly even burst, I guess, into a hosted version of the platform.
We had customers like that bursting out to the public cloud. Yeah.
Right. So getting into the actual, what does a user do? I love just like that simple UX of, it's not about, okay, go write the whole thing and go zip it up and put it, in a bucket, and then like go over here, find that bucket URL, pull it in. It's like, no. Sign up, say you want to create something, and right in there, I can just paste in my code, or edit the, example, and just say, like, go execute that thing. I just want to see what the web page says. And it gives that really quick feedback loop and easy entry, because people will want to scale it and do things automated later. But for the initial user, it's like, I just want to see this thing work. And can it do my script, or can it do, the thing that I want? And you can test that out with just the web IDE or web, text editor in a simple way, which is really cool. So here's the majority of kind of what we're talking about. And starting over here with this UI piece is like where that user interacts, and that just has you called it the decorator. It creates essentially, I don't remember if this created the tar, if the controller created the tar, but basically it takes the inputs and then sends it over to the controller, and the controller With
Yeah, Chris the Tar. Yeah, it's a Node.js application, so yeah.
Okay, so take that base64 encoded or whatever, send that over to controller with a HTTP puts, and the controller is responsible to like, okay, I'm going to actually put that in a database so that other things can access it, because I need to reference it, but I don't need to get it all the time. And I'm assuming that, metadata based on whatever, the customer that created it probably gets fed down, and other things just to be able to track that sort of information, what URL was given out for that code, all that sort of stuff. The controller is handling that from the sign up page, storing it, but then also this next piece down here of like the actual invoke of, hey, now, me as a user says, hey, I told you to run my Python code. Like, let me, like, here's the URL. What's the outputs? And the controller literally is getting is behind load balancer, I'm assuming, getting that input from a post and takes that metadata, creates the activation ID, which we have over here, and then shoves that whole thing into this message queue for the invokers into Kafka on different topics based on either what invoker it wants it to hit or what runtime it has, so that it knows that the invokers, the workers on the other end, will get the right thing, but also for that cold start situation of, hey, I've already seen this before. I just got this request. I'm going to put it back on the same queue, and that worker's still probably warm, to just save a lot of time for how that gets processed.
Yeah.
These workers are doing that fetch from the database and actually like pushing that into the runtime so that it gets invoked by the whatever runtime the user has selected. I love the notion of it being a parking lot of invokers that's just sitting there waiting for work to happen, or with their existing code waiting for it to be rerun, or just waiting to go away because like, okay, I've been here for a while, I should leave. Let the next clean implementation of this runtime come in. And then also the specifics around this is done via like hashing the code. So that helps you not only re-invoke that particular code, but also know if the user updated the code, right? So it's like that SHA becomes something different. And so I say, hey, I just changed my code. Controller stores that in the database, and then I invoke the same URL, shouldn't get the old code. And that's
exactly.
Hey, controller said, hey, I'm on version 2 now. Here's my hash. When the worker sees that, it says, I don't actually have that hash available yet. It doesn't care if it's the same user or not. It just says, oh, this is new code, I'm going to run it. I don't have a worker doing that thing yet, right?
Yeah, exactly. There's a hash as a version. Yeah, it gets hashed.
Yeah.
Every time you update your action. Yeah.
And then this over here is just as far as like the invoker details of the invoker itself is a controller that creates containers. Originally, I thought the invokers were like a one-to-one of each invoker was its own runtime, but that makes sense that you would have the invoker be another kind of scheduler for, hey, invoker is either on a full host and it can run these containers or these isolation boundaries, whatever the case may be, to run the code as it needs to, and it doesn't actually need another external scheduler to say like, oh, well, let me find your placement, because the invoker knows I have access to this instance or this VM or whatever the case. I can run all the stuff I need, and I don't need to. It's not a distributed system at the invoker level. It's a distributed code and running different forks of the code, but it's not actually coordinating over network boundaries. That requires just more latency, more queues, more load balancers, all these complexities once the code gets to the invoker level.
Yeah. And there's an implementation that the invoker can call out to Kubernetes API and say, like, run this code and find yourself a container in Kubernetes and run it. But that, like you said, there's a delay there, right, of finding a place, creating the pod, starting. So it's black box, but it's pluggable. So if speed is not the need there, you can also do
right.
it.
It's an option, but not necessary. So that makes sense. The pieces over here, as far as kind of what what breaks, or design decisions that kind of changed over time. I thought that was interesting as far as just, database swaps make sense. That's in a lot of applications, a lot of infrastructure. You start with one database and then someone says, well, I don't like that database, or I have expertise in this other database, or I don't have an admin there. So you have to swap out some of that just to abstract it away. But I think the really interesting thing here is like how users are using it. It's a good sign when a user comes in with a novel use case where they say, we hear like, oh, that wasn't how I intended to use this.
Yep.
But I think we can make that work. Whether that was just the basics of like, you need to train your users to say like, hey, like, don't do that. Like, you can functionally get the same thing without doing it that way. Either by storing, your giant picture or video file or whatever the case in another object store and not trying to send that through Kafka, because users don't need to know the implementation details of what goes through the message queue versus what is stored and fetched somewhere else.
Yep.
And then similar thing for these big functions down here for like the user doesn't really know what the limitation of how many libraries they can bring in, how big that tar file is once it's all, put together. They just know, I want to use these things because it makes my life easier. So please let me do that. Which is another.
That's why there's a lot of fast libraries and frameworks for users. Like one is favorite from Brian is architect from Begin, and they do Node.js, and they try to squeeze that function of all your dependencies like into like 5 meg, like no bigger than 5 megs or 3 megs to make your code starts faster.
Yep. Yeah, I mean, Node.js and Java are probably the two biggest kind of languages that'll just like explode to as much as they want because they're used to that sort of model of like, well, let's just pull in everything. It doesn't matter because in the past, or at least how they used to be executed, didn't really care about cold start. I mean, there's like when Java was created, there was no notion. I mean, cold start was a thing, but like cold start being a problem for returning HTTP, like, this server will run forever. Who cares? It's not this server runs and dies frequently.
Yeah, it takes literally 2 minutes to boot the container of Java, but the thing is like horsepower can do 10,000 requests per second, right? And threads.
Yeah. And then the last thing down here for how it's upgraded, at least in this implementation, I actually really like just how simple it is, where you break up your playbooks based on environment region and component, essentially. Just say like, hey, we don't have to redeploy everything if we don't want to. We don't have to redeploy everything everywhere. So I can target just the invokers in, region 7 in dev environments, and that works. And then also, I find it interesting that you do essentially, it sounded like you do the state store or the switching in Ansible, because Ansible has that ability to do checks that something is running, something's available, HTTP request, and then you wait to actually do the switches. It's not, as you mentioned, it's all automated. So I'm assuming this is Ansible playbook at the end of the run. Check that it's healthy. Okay, change that DNS entry point.
Yeah, I think I remember. Yeah, for the implementation, it will be different for everyone if they're using Cloudflare, like how to talk to Cloudflare to change the DNS, right? And route one cluster to another one, or talk to a load balancer in IBM Cloud or your cloud, or if you have NGINX. But the idea is like automation and orchestration of that rollout.
And using Ansible for that is very simple, because you don't have to go to another tool to say, is this healthy? Ansible can wait until it returns back a health check or whatever the case may be, and then say, oh, Ansible, also go talk to Cloudflare and do that thing for me.
Yeah. The important thing is practice. You can do it with Terraform, you can do it with shell scripts. Sure. I did a lot of Perl back in the days.
So that's basically it. That's kind of where we ended up. It's really neat just like seeing, I would assume like going into it, like, oh, I wonder how much performance you can get out of putting Kafka in the middle. Because, I always think of Kafka as having a lot of jobs, but as long as your workers pull it fast enough, it can be fast. almost as fast as just like a raw HTTP request, and just say like, okay, I stuck it on the queue, something reads it right away. You only have that like write delay, and then something else gets it. But the advantage of having all of your state inside of Kafka to be able to slowly pull things on and off on either side from the controller or the invokers makes Kafka just so much easier than trying to do that with blue-green load balancers between controllers and invokers.
Yeah, and this is a lot of work was done by IBM research in this area, and they chose Kafka because it was the fastest solution we could put there. Like HTTP was going to be holding connections. Will get messy very fast. So Kafka is something that is used in the enterprise, and it's like you can do, I don't know, ridiculous number of messages per second, right? As long as it's not a picture of 8 megs, please. But you can do a million messages per second, and people are like, what? I thought I can do that in HTTP. Like,
right.
No.
Yeah, and depending on your constraints of the system, it makes perfect sense to just say, and also the ability to essentially, with topics, doing load balancing to a sense of who's receiving or who's reading that by sending. The controller logic becomes really simple of send to Kafka, not coordinate my traffic between 50 different load balancers depending on metadata or where I sent it, and just say, hey, here's the topic, and just keep sending it to the same topic and never need to change that controller logic.
Yeah, and that's lessons from this project, right? It's being applied to Knative that works on Kubernetes for eventing. That not everyone knows how to write Kafka consumers and producers. So we are trying to, but would you want the benefits, the performance of Kafka? So in Knative eventing, the abstraction is MQ, RabbitMQ, or Kafka, and then the abstraction in Knative use cloud events. So you write your code in HTTP, but essentially it's going this same system of like the UI token HTTP, right? And then the container with your runtime is running HTTP, but the stuff in the middle is Kafka and abstraction. So that's something that it was applied from this project to Knative, which IBM is working on a new service called Code Engine that is like Knative as a service, which will be the next generation of this system.
Thank you so much, Carlos, for coming on the show and describing Cloud Functions to me. It was really exciting to see just what it took to build this from scratch and what it takes to run OpenWhisk at scale. If you're interested in the product itself, go ahead and check it out here at the website. And if you want to learn more about how developers build and run infrastructure, come back next week as we talk to another developer about how they're running their apps.